Power armor, conceived in the tense decades preceding the Great War of 2077, represents the apex of pre-war military innovation and a tangible reflection of humanity's obsession with survival and dominance in a world teetering on the brink of nuclear annihilation. Its origins deeply intertwined with both the United States military's strategic imperatives and the secretive industrial endeavors of private corporations such as General Atomics and West Tek, whose collaborations sought to create a mechanized exoskeleton capable of enhancing human physical capabilities while simultaneously providing unparalleled protection against the myriad threats of modern warfare. Beginning with the rising sophistication of conventional firearms, the introduction of nuclear and chemical weapons, and the global geopolitical tensions that defined the early 21st century, the conceptualization of powered armor drew heavily on decades of experimental research in robotics, hydraulics, and advanced metallurgy, with military engineers seeking a solution that could allow soldiers to bear immense weight, traverse hazardous environments, and survive conditions that would be fatal to unarmored troops, resulting in the creation of the T-45 prototype series, a suit designed to be both a mobile fortress and a platform for heavy weaponry, featuring hydraulic servos to multiply human strength, armor plating capable of resisting small arms, fire, and shrapnel, and an integrated environmental filtration system that would shield the wearer from chemical and radiological hazards, a design philosophy reflecting the dual priorities of survivability and lethality in pre-war combat doctrine. The early iterations of power armor were notoriously bulky and mechanically demanding, requiring extensive training for operation and careful maintenance. Yet, even these initial suits offered revolutionary advantages, allowing infantry to endure extreme battlefield conditions while carrying equipment that would otherwise be impossible for a single human to manage, a feature that prompted the U.S. military to deploy the T-45 inches specialized divisions, where their presence could serve as both a practical asset and a psychological deterrent against enemy forces. Simultaneously, research into energy-efficient power systems, including early fusion core prototypes, was underway to address the suit's immense energy requirements, as the servo mechanisms and environmental systems demanded a reliable source of high-density power to sustain prolonged operations. And while pre-war engineers achieved some success in miniaturizing energy cells and integrating them into the suits, limitations in battery, longevity, and weight remained significant, prompting ongoing refinement and eventual upgrades in subsequent models. The design ethos of the T-45 laid the groundwork for the T-51 series, which would become the definitive standard in power armor development, emphasizing modularity, improved mobility, and enhanced protective capabilities, incorporating advanced alloys capable of resisting high-velocity projectiles, increased radiation shielding, and more efficient hydraulic actuators, all while reducing the physical strain on the wearer, reflecting a broader military trend towards mechanized augmentation and the increasing reliance on technology to compensate for human limitations in warfare. Beyond the technical achievements, the creation of power armor also had profound implications for military strategy and doctrine, as units equipped with these suits could operate in environments previously considered impassable, including irradiated zones, chemical battlefields, and areas devastated by nuclear detonations, enabling pre-war commanders to project power in unprecedented ways. While the mere presence of power armor on the battlefield served as a potent symbol of technological supremacy, capable of demoralizing adversaries and emboldening Allied forces, the industrial collaboration that produced power armor involved complex coordination between military research laboratories, private contractors, and federal oversight agencies, with West Tek providing critical support in human factors engineering, ensuring that the suits were not only survivable, but also operable by trained personnel under the stress of combat, while General Atomics focused on the mechanical and energy systems, leveraging decades of innovation in robotics and servo mechanism design to create an exoskeleton that was both functional and durable. Alongside military applications, experimental programs explored civilian and security uses for powered exoskeletons, recognizing their potential for disaster response, hazardous material handling, and law enforcement. Though these initiatives were largely curtailed by the outbreak of nuclear war and the subsequent collapse of centralized government oversight, leaving most suits to be consigned to bunkers, armories, or specialized vaults designed to preserve critical technology, an action that would shape the post-apocalyptic distribution of power armor and make it a rare and highly coveted asset in the wasteland. The cultural and symbolic significance of power armor also emerged in pre-war media, military propaganda, and popular imagination, where it was celebrated as the ultimate protector of the American soldier, a near mythical fusion of human ingenuity and mechanized might, foreshadowing the role it would later play in the fractured societies of the post-nuclear world, where scavengers, militias, and factions such as the Brotherhood of Steel would come to regard it as both a tool of survival and a sacred artifact. Ultimately, the origins and development of power armor are inseparable from the historical context of the late 21st century, reflecting the anxieties, ambitions, and technological aspirations of a civilization on the brink of self-destruction, a civilization that invested immense resources into creating a tool that could grant its soldiers godlike strength, near-impervious defense, and the ability to endure environments that would otherwise be fatal, all while setting the stage for a legacy that would extend far beyond the Great War, influencing the structure, culture, and power dynamics of the post-apocalyptic world, and cementing power armor as an enduring icon of human resilience, ambition, and the dual-edged nature of technological advancement, a symbol that in the irradiated wastelands would come to define the difference between survival and oblivion for those fortunate or skilled enough to wield it. The T-45 Power Armor series, often regarded as the first mass-produced and operationally deployed powered combat suit in the history of the United States military, represents a critical evolution in pre-war military engineering, reflecting the culmination of decades of research in hydraulics, metallurgy, and battlefield ergonomics, and its development was driven by the recognition that conventional armor could no longer provide sufficient protection against the increasingly lethal arsenal of mid-21st century warfare, including high-velocity firearms, chemical agents, and the nascent threat of nuclear strikes. Designed and manufactured primarily by the Springfield Armory in collaboration with General Atomics, the T-45 was conceived as a versatile exoskeleton that could augment a soldier's physical capabilities while simultaneously providing a high level of protection, featuring reinforced alloys for impact resistance, servo-assisted limbs to enhance strength and endurance, and an integrated environmental system that filtered airborne toxins, radiation, and particulate matter, allowing the wearer to operate in conditions that would prove fatal to unarmored troops. And this combination of protective and augmentative features positioned the T-45 as a strategic asset in both offensive and defensive operations across a range of pre-war scenarios. The suit's distinctive design, characterized by its bulky frame, reinforced helmet with heads-up display, and articulated joints powered by hydraulic actuators, was intended to provide maximum survivability while maintaining operational mobility, though early models were cumbersome, heavy, and required extensive training for effective use, a factor that limited initial deployment to specialized infantry units and elite task forces tasked with operating in high-risk environments where their presence could tip the balance of combat engagements and provide a psychological advantage over enemy forces, as the sight of a fully armored T-45 unit moving steadily through battlefield terrain could inspire fear, awe, and caution among opposing soldiers. The armor's internal systems were powered by compact, high-output fusion cells, which supplied energy to the hydraulic servos, environmental filtration, and integrated communication systems, allowing soldiers to carry heavier weapons, traverse difficult terrain, and sustain prolonged operations without succumbing to exhaustion. Though the reliance on fusion technology also introduced vulnerabilities, including limited operational duration, susceptibility to overheating, and the logistical challenge of maintaining and replacing energy cores in the field, which prompted the military to develop rigorous maintenance protocols and specialized support units to ensure peak performance, further emphasizing the T-45's role not just as armor, but as a technological centerpiece of pre-war military doctrine. The modular nature of the T-45's design allowed for incremental improvements and field modifications, enabling engineers to adapt the suit to various combat roles, from heavy assault operations to reconnaissance missions in contaminated zones, and this adaptability facilitated the creation of specialized variants, including reinforced shoulder plates, enhanced limb actuators, and integrated weapon mounts, reflecting the military's strategic emphasis on versatility and technological superiority, and establishing a design philosophy that would influence all subsequent iterations of power armor, including the legendary T-51 series. The operational history of the T-45, while limited by the onset of the Great War, demonstrates its effectiveness as both a defensive and offensive platform, with pre-war military records indicating deployment in scenarios ranging from domestic security operations to overseas interventions, where its protective capabilities and strength augmentation provided a tangible tactical advantage over unarmored or lightly armored adversaries. And even in non-combat roles, the T-45's ability to allow soldiers to carry heavy loads and traverse hazardous terrain extended the operational range and endurance of units tasked with engineering, logistical, and exploratory missions. The T-45's helmet, a technological marvel in its own right, featured an integrated heads-up display that provided real-time battlefield data, including ammunition counts, environmental conditions, targeting reticles, and unit coordination information, enhancing situational awareness and tactical decision-making for the wearer, while the internal communication system allowed for encrypted squad-level coordination, a critical feature in pre-war doctrine emphasizing unit cohesion, rapid response, and adaptability under the stress of combat. Post-war, the T-45 became one of the most commonly encountered suits of power armor in the wasteland, its durability and relative simplicity making it both a target for scavengers and a cornerstone of the technological arsenal for emergent factions such as the Brotherhood of Steel, who dedicated significant resources to recovering, refurbishing, and reverse engineering surviving units, studying their mechanical and energy systems to preserve knowledge and maintain a monopoly on advanced military technology, and in some cases, modifying the T-45 to integrate components from later models. creating hybrid suits that retained the original design's ruggedness while benefiting from enhanced mobility, energy efficiency, and protective capability. The T-45's influence extended beyond its immediate military applications, serving as a template for civilian and paramilitary adaptations, including industrial exoskeletons, disaster response units, and experimental security platforms, demonstrating the enduring significance of its mechanical architecture and the broader pre-war ambition to mechanize human labor and combat effectiveness, a vision that would continue to resonate in the fractured societies of the post-nuclear world, where power armor remained a symbol of authority, technological mastery, and survival. Culturally, the T-45, with its distinctive bulk, rounded helmet, and imposing silhouette, came to embody the duality of pre-war American technological ambition and militaristic culture, appearing in media, propaganda, and recruitment materials as a representation of strength, resilience, and the protective might of the United States, and its legacy persisted after the Great War, shaping faction identities, inspiring scavenger myths, and reinforcing the perception of power armor as an artifact not merely of technology, but of authority and status, a perception that elevated even the battered and incomplete T-45 suits found in the wasteland to the level of relics, treasure, and symbols of legitimacy for groups like the Brotherhood of Steel, the Enclave, and other organized factions, seeking to assert control over territory and resources. In practical terms, the T-45's design demonstrated both the promise and the limitations of early powered armor technology, with its formidable protective capacity and strength, augmentation offset by challenges in energy management, joint mobility, and environmental integration, providing invaluable lessons that informed subsequent iterations, including the T-51, T-60, and X-1 series, which sought to refine armor alloys, servo efficiency, and core power consumption while addressing ergonomic and operational shortcomings, and these evolutionary steps underscore the T-45's role as a foundational model in the lineage of pre-war and post-war armored warfare, highlighting how a single technological breakthrough can define both historical and post-apocalyptic military paradigms, shaping combat strategy, factional power structures, and the cultural imagination of survivors across generations. The legacy of the T-45 power armor series, therefore, is not confined to its immediate battlefield impact, but extends into the post-apocalyptic era as a symbol of innovation, survival, and authority. An artifact whose recovery, restoration, and deployment by post-war factions exemplify the enduring relevance of pre-war technology in shaping the destinies of those navigating the irradiated wastelands, where strength, protection, and the ability to endure environmental hazards remain as vital as they were in the decades before the bombs fell, ensuring that the T-45's place in history is secure not only as the first operational powered suit, but as the cornerstone of a technological tradition that continues to define the very concept of survival in Fallout's harsh and unforgiving world. The T-51 power armor series, widely regarded as the pinnacle of pre-war armor design and the direct evolutionary successor to the T-45, embodies decades of accumulated technological innovation, battlefield experience, and lessons learned from early operational deployments, representing the United States military's most ambitious attempt to create a fully integrated combat exoskeleton that could offer unmatched protection, strength augmentation, and operational versatility and its development reflects both the military's response to escalating global threats and the pre-war industrial capacity that sought to equip the armed forces with a technological advantage capable of shaping the outcome of modern warfare. Unlike the T-45, which had been constrained by the limitations of materials, hydraulics, and energy efficiency, the T-51 incorporated advanced alloys that were lighter yet more resilient, capable of resisting small arms fire, shrapnel, and even limited nuclear radiation exposure, while simultaneously improving the hydraulic servo mechanisms and joint articulation to enhance mobility, endurance, and overall combat effectiveness, allowing soldiers to traverse difficult terrain, carry heavier weaponry, and survive in environments that would have been otherwise fatal, including irradiated zones, chemical warfare fields, and areas devastated by pre-war conventional and nuclear strikes. And these improvements made the T-51 not only a practical combat tool, but also a symbol of pre-war technological ambition and military supremacy. The T-51's modular design marked a significant leap forward, allowing for easier maintenance, component replacement, and upgrades. And it was engineered with an integrated environmental filtration system that could manage airborne toxins, radiation, and particulate matter, while also featuring a heads-up display within the helmet that provided real-time battlefield data, including ammunition tracking, targeting reticles, navigation aids, and squad-level communications, a level of situational awareness that far exceeded the T-45 and gave the wearer a decisive advantage in both individual and unit-level engagements, while simultaneously establishing a new standard for power armor, ergonomics, and usability that would influence subsequent designs such as the T-60 and X-1. Among the variants of the T-51, the T-51B model became the most widely recognized and deployed, prized for its optimal balance of protection, mobility, and energy efficiency, incorporating a redesigned helmet with improved optics, a reinforced chest plate for maximum survivability, and a more streamlined joint structure that allowed for greater agility in combat, reflecting a military doctrine that increasingly emphasized rapid, mechanized infantry capable of both sustained operations and high-intensity engagements, and pre-war military records indicate that the T-51B was deployed in a variety of theaters, from domestic defense assignments to overseas interventions, where it demonstrated superior battlefield performance compared to earlier models, and its durability, reliability, and protective capabilities quickly made it the gold standard for powered infantry units. Powered by advanced pre-war fusion cores, the T-51 series could operate for extended periods without interruption, allowing soldiers to maintain combat readiness during prolonged engagements and traverse hazardous zones without immediate logistical support, though the reliance on these high-density energy sources also introduced critical dependencies, requiring careful monitoring, maintenance, and eventual replacement, and these considerations shaped both pre-war operational planning and post-war recovery efforts, as surviving fusion cores became highly coveted components among scavengers, factions, and the Brotherhood of Steel, who sought to secure and preserve this technology to maintain their dominance in the post-apocalyptic landscape. The T-51's mechanical systems, including reinforced servos, actuators, and exoskeletal supports, allowed soldiers to carry heavier ordnance, traverse uneven terrain, and endure prolonged engagements without fatigue, transforming the role of the individual soldier into that of a mobile armored platform capable of exerting immense force. And this capability had profound implications for pre-war military strategy, enabling units equipped with T-51 armor to execute operations that were previously impossible for unarmored infantry. From high-risk assault missions to specialized reconnaissance in contaminated zones, and establishing a new paradigm for mechanized warfare that prioritized technological augmentation over sheer numbers or conventional tactics. Post-war, the T-51 series emerged as a defining artifact of the wasteland, with surviving suits becoming the foundation of factional power, most notably for the Brotherhood of Steel, whose scavenging operations, technical expertise, and preservation efforts ensured that T-51 armor remained a central component of their martial and cultural identity, serving both as a tool of warfare and a symbol of authority, technological mastery, and the pre-war ideals of military supremacy, while also influencing other factions, opportunistic scavengers, and independent operators who sought to leverage the armor's unparalleled defensive and offensive capabilities for survival, territorial control, or personal gain. The T-51's legacy is further reinforced by its appearances in popular pre-war media, propaganda, and recruitment campaigns, which depicted the armor as the ultimate protector of American ideals, embodying strength, resilience, and technological ingenuity. And this cultural prominence persisted into the post-apocalyptic era, where the visual recognition of T-51 armor could instill fear, respect, or allegiance among wasteland dwellers, effectively transforming the suit from a purely functional piece of military hardware into a symbol of power, authority, and survival, and creating a mythology around the armor that elevated even incomplete or damaged suits to near mythical status. Technically, the T-51 addressed many of the shortcomings of the T-45, including excessive bulk, joint strain, and energy inefficiencies, through the implementation of lightweight alloys, improved hydraulic systems, and optimized energy consumption. And its modular components allowed for field repairs, customizations, and incremental upgrades, such as reinforced limb plates, integrated weapon mounts, and enhanced sensor arrays, which could be tailored to the operational requirements of individual soldiers or units, reflecting a design philosophy that emphasized flexibility, adaptability, and long-term sustainability, principles that would inform later models like the T-60 and X-1, and demonstrating the pre-war commitment to technological evolution and battlefield efficacy. In combat applications, the T-51 series fundamentally altered infantry tactics and engagement strategies, providing soldiers with a level of survivability and offensive capability that could decisively influence battlefield outcomes, enabling small units to perform missions traditionally requiring larger forces, sustaining operations in irradiated or chemically contaminated areas, and serving as mobile strongpoints capable of withstanding concentrated enemy fire while delivering devastating counterattacks. And these capabilities established the T-51 as a cornerstone of pre-war military doctrine, emphasizing technological superiority, force multiplication, and strategic flexibility in both conventional and asymmetric warfare. The preservation, refurbishment, and operational use of T-51 suits in the post-war wasteland underscores their enduring relevance, as factions like the Brotherhood of Steel, Enclave remnants, and independent operatives prioritize securing these suits not only for their practical utility, but also for the symbolic authority they confer, with intact T-51 armor becoming both a tangible asset and a statement of power, often inspiring myth, legend, and fear in a landscape defined by scarcity, conflict, and the struggle for survival, ensuring that the T-51's impact extends far beyond its original military intent, shaping factional identity, tactical doctrine, and the cultural imagination of the wasteland. Ultimately, the T-51 Power Armor series represents the apex of pre-war technological achievement in personal armor, combining enhanced survivability, strength augmentation, mobility, environmental protection, and integrated battlefield systems, while also influencing post-apocalyptic society through its symbolic weight, factional significance, and practical utility, creating a legacy that endures across decades, conflicts, and wasteland generations, cementing the T-51 not only as the standard bearer of powered infantry, but as an enduring icon of human ingenuity, ambition, and the intersection of technology and survival in the Fallout universe. The T-60 Power Armor series, representing the culmination of pre-war armored infantry development prior to the Great War, and the evolutionary bridge between the venerable T-51 and the experimental X-1 models, stands as a testament to the military's ongoing commitment to improving survivability, mobility, and combat effectiveness. Developed during the final years of the United States pre-apocalyptic defense programs, as global tensions escalated and the perceived threat of nuclear engagement became imminent, and it embodies both the lessons learned from earlier T-45 and T-51 deployments, as well as the adaptation of emerging technological innovations, including improved alloys, enhanced hydraulic systems, and more efficient energy management, reflecting a broader military philosophy that sought to create a suit capable of withstanding not only conventional warfare, but also the catastrophic conditions of nuclear devastation. The T-60 was primarily produced by the Enclave's affiliated contractors and certain divisions of the U.S. military with the intent of standardizing power, armor deployment across specialized units, while optimizing performance in environments contaminated by radiation, chemical agents, and conventional battlefield hazards, incorporating a combination of lighter, more resilient metals and reinforced plating that provided exceptional protection against ballistics, shrapnel, and environmental hazards, while improving joint articulation and wearer comfort, a significant advancement over the bulkier T-51 series, which, despite its legendary status, presented limitations in mobility, long-term wear, and adaptability under extreme conditions, and the T-60 sought to rectify these issues, while also integrating modular components that could be customized for mission-specific requirements. From heavy assault to reconnaissance operations, the suit's servo-mechanical systems were upgraded to provide greater strength augmentation, allowing soldiers to carry heavier ordnance, traverse steep or uneven terrain, and perform sustained combat operations without succumbing to fatigue. While the power source, typically a pre-war miniaturized fusion core, delivered higher energy output with improved efficiency, extending operational endurance and reducing the frequency of maintenance cycles, a critical factor in both pre-war strategic planning and post-war scavenging operations, as fusion cores became increasingly rare and valuable in the irradiated wasteland, with factions such as the Brotherhood of Steel prioritizing their acquisition, preservation, and integration into recovered T-60 units to maintain their technological supremacy. The helmet and sensory systems of the T-60 represented a significant evolution in battlefield awareness, incorporating enhanced optical sensors, integrated environmental monitoring, and heads-up displays that provided real-time tactical information, including threat detection, ammunition status, unit coordination, and radiation mapping, creating a level of situational awareness unparalleled in previous models, and enabling soldiers to operate effectively in chaotic or high-risk scenarios, while communication arrays allowed for secure, encrypted squad-level coordination, reflecting pre-war military doctrine that emphasized technological augmentation as a force multiplier and the need for cohesive, informed decision-making under fire. Operationally, the T-60 was deployed in limited numbers prior to the outbreak of the Great War, with the majority of production allocated to elite units, enclave-affiliated security forces, and specialized response teams. And although the nuclear exchange curtailed widespread deployment, surviving units became highly coveted artifacts in the post-apocalyptic era, representing both functional power and symbolic authority, as the suit's advanced capabilities and imposing appearance conferred legitimacy, intimidation, and tactical superiority to those fortunate enough to possess them, whether scavengers, factional militias, or the technologically disciplined Brotherhood of Steel, who regarded the T-60 as both an extension of their martial prowess and a sacred relic of pre-war civilization. The T-60's modularity allowed for the integration of additional armor plating, weapon mounts, and environmental systems, reflecting a design philosophy that emphasized adaptability, ease of repair, and mission-specific customization, with suits configured for heavy infantry assaults, radiation hazard operations, or command roles that required enhanced communications and monitoring, and this flexibility ensured that the T-60 could maintain operational relevance even as battlefield conditions and tactical requirements evolved, a principle that became essential in the fractured and resource-scarce post-war wasteland, where improvisation, modification, and salvage determined survival. One of the critical innovations of the T-60 was its improved fusion core interface and energy distribution system, which not only extended operational duration, but also allowed for more efficient allocation of power to hydraulic servos, environmental systems, and integrated weapon systems, addressing the limitations of the T-51 and T-45 while demonstrating a keen understanding of the logistical challenges inherent in sustained powered infantry deployment and in post-war recovery scenarios. The T-60's energy systems became a focal point for factions seeking to restore or replicate pre-war technology, driving research, reverse engineering, and experimentation with hybridized designs that combined the T-60's durability and efficiency with recovered components from earlier or experimental armor. Culturally, the T-60 carried forward the symbolic weight established by the T-51, serving as both a functional combat suit and a visual representation of authority, technological mastery, and pre-war military ideology. And in the post-apocalyptic context, this symbolism was amplified, as the sight of a T-60-clad soldier could inspire fear, loyalty, or reverence, shaping the social dynamics and power hierarchies of wasteland factions, while also perpetuating myths, legends, and stories surrounding the armor, which became intertwined with the identity of groups like the Brotherhood of Steel, whose members often regarded T-60 suits as both sacred artifacts and essential instruments of dominance. In terms of mechanical engineering, the T-60 incorporated advanced alloys capable of withstanding ballistic and explosive forces, a redesigned exoskeleton for improved load-bearing and flexibility, and enhanced servo-actuated joints that reduced strain on the wearer while increasing lifting and carrying capacity, all of which addressed operational shortcomings identified in the T-51 series while the helmet's sensor suite allowed for enhanced targeting, threat recognition, and environmental monitoring, providing the wearer with a decisive advantage in combat scenarios, particularly in hazardous zones where visibility, radiation, or chemical contamination would otherwise compromise effectiveness. Post-war, the T-60's survival and operational relevance depended heavily on factional recovery, repair, and adaptation, with the Brotherhood of Steel recovering intact or salvageable suits and using them as both a combat resource and a technological benchmark, while other groups, including the remnants of the Enclave and independent scavengers, sought to claim the armor for its practical utility, energy systems, and symbolic authority, demonstrating the enduring importance of the T-60 inches shaping post-apocalyptic military strategy, factional identity, and technological preservation. Additionally, the T-60 exemplifies the broader trajectory of pre-war power armor development, illustrating the military's commitment to iterative improvement, adaptability, and the integration of advanced materials, energy efficiency, and user-centered design. Lessons that would inform not only subsequent experimental models such as the X-1, but also the post-war understanding of powered exoskeleton applications ranging from combat to environmental hazard navigation, load-bearing, and strategic dominance. In combat doctrine, the T-60 transformed operational strategy by allowing small, technologically enhanced units to perform missions that would have previously required larger forces, providing enhanced survivability, mobility, and lethality, while enabling a degree of autonomy and force multiplication previously unattainable with conventional infantry. And this strategic shift underscores the military's reliance on technological innovation to achieve battlefield supremacy, a principle that persisted into the fragmented societies of the wasteland, where access to T-60 armor could determine the balance of power, territorial control, and survival. Ultimately, the T-60 Power Armor series represents both the culmination of pre-war powered armor evolution and a critical link in the lineage of military exoskeletons, bridging the T-51's operational legacy and the experimental ambitions of the X-1, while continuing to shape the post-apocalyptic world through its technological sophistication, combat effectiveness, and enduring symbolic significance, cementing its status as a cornerstone of pre-war innovation, factional authority, and the enduring mythology of survival, power, and resilience in the irradiated wastelands of Fallout. The X-1 power armor, the apex of pre-war experimental armored technology, and the most advanced combat exoskeleton developed by the United States before the Great War of 2077, represents a radical departure from previous designs, such as the T-45, T-51, and T-60, combining cutting-edge materials, science, energy efficiency, and modular engineering with an emphasis on battlefield dominance and strategic versatility, and its creation reflects the military-industrial complex's relentless pursuit of technological superiority in an era defined by nuclear brinkmanship, escalating global conflict, and the anticipation of total war. Conceived as a prototype for a next-generation infantry platform, the X-1 series incorporated advanced alloys far superior to those used in earlier models, capable of withstanding small arms fire, high-caliber projectiles, and extreme radiation exposure, while maintaining structural integrity under explosive or mechanical stress, and these improvements were complemented by state-of-the-art hydraulic and servo systems that enhanced strength, endurance, and mobility. allowing soldiers to carry unprecedented loads, traverse rugged terrain, and sustain prolonged engagements in environments that would have incapacitated unarmored personnel, a design philosophy that emphasized survivability, lethality, and strategic flexibility in a single wearable platform. Energy efficiency was a defining feature of the X1, with its fusion core interface optimized to deliver maximum power to hydraulic actuators, environmental filtration systems, integrated communications, and sensory arrays, allowing for extended operational duration without compromising performance. And while early prototypes encountered challenges related to energy management, overheating, and component wear, iterative testing and refinement resulted in a suit that represented the zenith of pre-war powered armor technology, combining resilience, adaptability, and battlefield supremacy in a single unit. The helmet and sensory systems of the X1 were a leap forward from previous models, integrating multi-spectrum optics, advanced heads-up displays, threat detection, tactical overlays, and real-time environmental monitoring, providing unparalleled situational awareness and enhancing decision-making under combat conditions. While secure, encrypted communications allowed for effective coordination between units, enabling tactical maneuvers and command execution that were previously impractical with conventional infantry formations, and these systems established a new standard for power armor technology, influencing the development of post-war suits recovered and modified by factions such as the Brotherhood of Steel and the Enclave. Structurally, the X1 was designed for maximum modularity, allowing components to be replaced, upgraded, or customized according to mission requirements, whether for heavy assault, reconnaissance, or environmental hazard operations, and this adaptability extended to armor plating, weapon integration points, sensor suites, and joint augmentation, reflecting a pre-war doctrine that prioritized flexibility and long-term sustainability, and ensuring that surviving units could continue to provide tactical advantage in the post-apocalyptic wasteland, despite the scarcity of maintenance resources, replacement parts, and fusion cores. Operationally, the X1's deployment was extremely limited due to the high cost, experimental nature, and secrecy surrounding the project, with records indicating allocation primarily to elite units, experimental task forces, and enclave-controlled facilities. And although the outbreak of nuclear war curtailed mass production, surviving prototypes became highly prized artifacts in the wasteland, sought after not only for their unmatched protective and augmentative capabilities, but also for the symbolic authority they conferred, as the presence of an X1 suit could inspire fear, reverence, or loyalty among wasteland survivors, reinforcing social hierarchies and factional power dynamics in a world defined by scarcity, conflict, and survival. The X1 also represents a philosophical and technological milestone, embodying the pre-war ambition to create a fusion of human and machine that could transcend conventional limitations, combining physical enhancement, environmental resilience, and battlefield intelligence in a single unit. And its design reflects decades of accumulated knowledge from previous T-Series models, lessons learned from field testing, and advances in metallurgy, hydraulics, energy distribution, and sensory technology, making it the definitive expression of powered infantry engineering. In terms of factional post-war significance, the X1 became the ultimate prize for the Brotherhood of Steel, the Enclave, and other technologically inclined groups, with its rarity, complexity, and superiority, cementing it as both a practical tool of warfare and a symbol of pre-war achievement, authority, and legitimacy, and recovery operations often involved extensive exploration, scavenging, and reverse engineering to understand and replicate its advanced systems, which remained largely inscrutable due to the secrecy and sophistication of the original design, emphasizing the enduring value of the X-1 as a benchmark for technological mastery. The armor's impact on battlefield strategy was profound, providing small units with a level of protection, firepower, and environmental adaptability that allowed them to operate in highly contested zones, endure extreme conditions, and dominate engagements that would have overwhelmed conventional forces, effectively multiplying the operational effectiveness of individual soldiers and reflecting a pre-war military doctrine that increasingly prioritized technological supremacy and mechanized augmentation over sheer numerical advantage or conventional tactics. Mechanically, the X-1 incorporated enhanced servo-mechanical joints, reinforced exoskeletal frames, and advanced load-bearing systems, allowing soldiers to lift, carry, and manipulate heavier weaponry, ammunition, and equipment than ever before, while maintaining mobility and agility, and the armor's fusion core-powered systems ensured consistent performance even under prolonged exertion, enabling the wearer to sustain combat operations across irradiated landscapes, chemically contaminated zones, or areas devastated by conventional or nuclear explosions, which would have rendered other powered armor models ineffective or compromised. The X-1 also integrated advanced environmental systems, including air filtration, climate control, and radiation shielding, which allowed operators to function safely in conditions that would otherwise prove fatal, a feature that reinforced the armor's strategic value in post-apocalyptic exploration, combat, and survival, and contributed to its mythic status among wasteland factions, who often regarded it as both a technological marvel and a symbol of untouchable power. Culturally, the X-1 power armor embodies the dual nature of pre-war ambition and post-war myth, serving as a tangible representation of human ingenuity, the limits of technological achievement, and the persistence of authority through material symbols, with surviving suits inspiring legends, reverence, and fear among scavengers, raiders, and faction members, and reinforcing the idea that access to advanced technology equates to power, legitimacy, and survival in the irradiated wastelands. Its legacy extends beyond its immediate functionality, influencing post-war faction identity, factional warfare, and the hierarchical distribution of resources, while also shaping the cultural imagination, storytelling, and mythology of the wasteland, elevating the X-1 from a prototype suit to a symbol of pre-war technological ambition and post-war survival, a testament to the enduring impact of innovation, engineering, and military foresight in the Fallout universe. Ultimately, the X-1 power armor represents the pinnacle of pre-war powered armor technology, synthesizing decades of experience, innovation, and battlefield feedback into a suit that is unmatched in protection, strength augmentation, mobility, and tactical versatility, and its enduring presence in the wasteland underscores not only its practical superiority, but also its symbolic weight as a representation of pre-war ambition, technological mastery, and human resilience in the face of annihilation, solidifying its place as an iconic artifact and cornerstone of powered armor history within the Fallout universe. The functionality and mechanics of power armor in the Fallout universe represent the apex of pre-war military engineering, combining advanced mechanical systems, energy distribution, environmental protection, and human augmentation into a single, integrated platform designed to enhance both survivability and combat effectiveness. And understanding these systems requires a detailed examination of the intricate interplay between servomechanics, hydraulics, energy sources, armor alloys, environmental filtration, and sensor integration, all of which contribute to the unique operational capabilities of suits, ranging from the earliest T-45 series to the experimental X-1 models, reflecting decades of research, iterative refinement, and battlefield feedback. At the core of every suit lies the exoskeletal framework, a complex assembly of reinforced alloy plates, hydraulic actuators, and servomechanical joints that amplify the wearer's strength, endurance, and dexterity, allowing soldiers to lift and carry loads far exceeding human capability, traverse uneven or treacherous terrain, and sustain high-intensity combat operations over prolonged periods without succumbing to fatigue. A capability that fundamentally transforms the role of the individual soldier into that of a mobile, armored force multiplier capable of performing tasks traditionally requiring multiple personnel or specialized machinery. The hydraulic and servo-assisted limbs, often powered by pre-war fusion cores, act as both structural support and kinetic augmentation, converting electrical energy into mechanical motion to multiply the force exerted by the wearer, while precision-engineered joint assemblies ensure that movement remains fluid, responsive, and energy efficient, addressing the inherent challenges of coordinating a complex exoskeleton with human biomechanics and providing the wearer with an intuitive interface that responds to natural motion while protecting against overextension or mechanical failure, a feat of engineering that represents the culmination of decades of biomechanical research and iterative design testing across multiple armor series. Integrated energy distribution systems, centered around miniaturized fusion cores, serve as the lifeblood of power armor, supplying sustained electrical power to hydraulic servos, environmental filtration, sensor arrays, communication systems, and heads-up displays, while advanced circuitry and redundant pathways ensure consistent performance even under extreme stress or partial system failure, and these energy networks are carefully calibrated to optimize power allocation, allowing critical systems such as limb movement, protective shielding, and environmental monitoring to operate without interruption, while non-essential systems can be throttled or shut down to conserve energy in prolonged field operations, a capability that underscores the military's focus on operational endurance, tactical versatility, and strategic reliability. Environmental protection is a cornerstone of power armor functionality, with integrated filtration systems designed to remove airborne toxins, chemical agents, particulate matter, and radioactive isotopes, while temperature regulation and climate control systems allow soldiers to maintain performance in extreme heat, cold, or irradiated zones, effectively insulating the wearer from conditions that would prove fatal to unarmored personnel. And these features were further enhanced in late models such as the T-60 and X-1, which incorporated advanced radiation shielding, redundant filtration pathways, and adaptive environmental monitoring, enabling operation in post-nuclear landscapes, irradiated wastelands, or areas contaminated by industrial chemical runoff, reflecting a pre-war emphasis on survivability in all conceivable combat and environmental scenarios. The heads-up display, integrated into the helmet of each armor variant, provides a comprehensive information overlay, including threat detection, ammunition tracking, environmental hazards, tactical overlays, unit coordination, and navigation aids, creating a level of situational awareness unattainable with conventional equipment, while allowing the wearer to process battlefield data in real time, make informed tactical decisions, and maintain unit cohesion, a function further enhanced by secure, encrypted communications networks that link multiple armor-clad soldiers or command units, facilitating coordinated maneuvers, rapid responses to emerging threats, and the execution of complex mission objectives, a feature that reflects the pre-war military doctrine of combining technological augmentation with strategic coordination to maximize combat effectiveness. Maintenance and modularity are integral aspects of power armor mechanics, with each suit designed to allow field repairs, component replacement, and incremental upgrades, including reinforced limb actuators, additional armor plating, sensor suite enhancements, and integrated weapon mounts, enabling customization for mission-specific requirements and prolonging operational lifespan, a consideration that became critical in post-war wasteland recovery scenarios, where salvaged components, hybridized systems, and improvised repairs often determined whether a suit could remain functional, and where factions such as the Brotherhood of Steel developed extensive technical manuals, workshops, and salvage operations to maintain and preserve power armor as both a tactical asset and a repository of pre-war technological knowledge. Mechanical integration also extends to mobility and ergonomics, as the suits are engineered to accommodate a range of human body types while providing stability, balance, and responsive movement, with careful calibration between joint articulation, servo response, and user input, ensuring that the enhanced strength does not compromise agility, reaction time, or precision. A challenge addressed through decades of iterative testing, refinement, and biomechanical analysis, and a defining characteristic of the T51, T60, and X1 series, where fluid movement, operational efficiency, and user safety converge to create a suit that feels like an extension of the human body rather than an encumbrance. Armor plating and material selection are central to both protection and weight management, with pre-war engineers employing high-strength alloys, composite materials, and layered plating strategies to optimize ballistic resistance, explosive deflection, and environmental shielding while minimizing the energy required for movement. And late-series suits introduced adaptive plating configurations, reinforced joints, and modular panels that could be replaced or upgraded based on mission needs, highlighting the dual objectives of protection and maintainability that underpin power armor design philosophy. Weapon integration and tactical augmentation further exemplify the mechanics of these suits, with mounting points, stabilizing systems, and energy conduits allowing soldiers to wield heavier firearms, energy weapons, and heavy ordnance with enhanced precision, while the hydraulic servos absorb recoil, reduce physical strain, and facilitate rapid target acquisition, effectively transforming the soldier into a mobile weapons platform capable of sustained, high-intensity engagement and enabling operational strategies that emphasize technological force multiplication over sheer numbers, a principle that carries forward into the post-war utilization of armor by factions seeking both practical and symbolic advantage. Operational safety systems, including overload protection, joint torque limits, and automated alerts for environmental hazards or system malfunctions, further reflect the engineering sophistication of power armor, ensuring that the wearer can operate at peak efficiency without risking mechanical injury, fatigue, or system failure. and these features were continuously refined across T-series models, culminating in the X1's advanced automated diagnostics, redundant servo mechanics, and integrated threat monitoring, a suite of capabilities that positioned it as the ultimate embodiment of pre-war exoskeletal engineering. The fusion of mechanical, electrical, and environmental systems within each suit exemplifies a holistic approach to combat engineering, where strength, augmentation, protection, endurance, mobility, situational awareness, and energy management are interdependent, and any deficiency in one system directly impacts the overall operational effectiveness. A design philosophy that underscores the meticulous planning, iterative testing, and cross-disciplinary expertise invested in each generation of power armor, while simultaneously providing post-war survivors and factions with a blueprint for understanding, repairing, and adapting these suits in a resource-scarce, hazardous environment. In post-apocalyptic applications, the functionality and mechanics of power armor remain central to survival, combat effectiveness, and factional dominance, with scavenged fusion cores, improvised repairs, and hybridized upgrades, enabling wasteland operators to extend operational lifespan, enhance combat capability, and assert authority. And the armor's integrated systems, servo mechanics, hydraulics, environmental filtration, and sensor arrays continue to confer decisive advantages to those capable of mastering their complexities, ensuring that power armor retains both its practical utility and symbolic significance across generations. Ultimately, the functionality and mechanics of power armor represent a marriage of pre-war ambition, engineering mastery, and battlefield pragmatism, with each suit embodying decades of research, iterative design, and strategic foresight, creating an exoskeletal platform that transforms human capability, enables survival in extreme environments, and establishes a technological hierarchy that continues to define power, authority, and resilience in the Fallout universe, illustrating the profound impact of integrated mechanical systems on both combat and post-apocalyptic society, and cementing power armor as the definitive symbol of pre-war technological achievement and enduring wasteland dominance. The materials and engineering behind power armor in the Fallout universe reflect the apex of pre-war metallurgical science, mechanical design, and industrial innovation, representing a meticulous synthesis of strength, durability, weight optimization, and functional resilience. And each generation of powered armor, from the T-45 through the T-51, .60, and X1 series, demonstrates the evolution of engineering solutions aimed at creating a wearable exoskeleton capable of surviving both conventional warfare and the catastrophic environmental conditions anticipated in the nuclear age, with designers prioritizing ballistic resistance, radiation shielding, and structural integrity while maintaining mobility, endurance, and user safety, a feat achieved through decades of iterative development, research, and field testing. Early power armor, exemplified by the T-45, relied on high-strength steel alloys combined with hydraulic and servo-mechanical enhancements to amplify the wearer's physical strength, protect against small arms fire, shrapnel, and chemical hazards, and provide operational stability in challenging terrain. And while effective for its time, the bulk and weight of these materials imposed limitations on mobility, energy efficiency, and operational duration, leading engineers to experiment with lighter, higher-strength alloys, advanced composites, and modular construction techniques in subsequent designs, a progression that culminated in the T-51B and later models, which balanced protection and maneuverability in ways that significantly enhanced battlefield utility. The T-51 series marked a significant milestone in materials engineering, employing refined alloys that combined tensile strength with reduced weight, allowing for improved joint articulation, servo responsiveness, and energy efficiency, while the addition of reinforced plating, layered armor sections, and strategically placed shielding enhanced survivability against a variety of threats, including high-velocity projectiles, explosive ordnance, and environmental radiation, demonstrating a sophisticated understanding of material science principles, stress distribution, and operational ergonomics, and establishing a standard for subsequent iterations that would incorporate these lessons into increasingly advanced designs. By the time of the T-60 series, material engineering had advanced to include specialized alloys designed to resist not only conventional projectiles, but also extreme thermal and radiological stress, and designers implemented modular plating systems that could be repaired, replaced, or upgraded in the field, reflecting an emphasis on maintainability, adaptability, and mission-specific customization, with attention paid to minimizing the overall mass of the suit to reduce energy consumption, enhance agility, and prevent overtaxing the hydraulic servos and fusion power systems, a consideration critical in both pre-war operations and post-war scavenging contexts, where functional integrity often depended on the availability of scarce replacement parts, fusion cores, and maintenance expertise. The X-1 power armor represents the pinnacle of materials and engineering innovation, incorporating advanced, experimental alloys with exceptional tensile strength, radiation resistance, and energy absorption capabilities, while integrating redundant structural supports, enhanced servo systems, and modular armor plating that could withstand catastrophic damage, sustain operational integrity, and adapt to diverse battlefield conditions, embodying a holistic approach to mechanical engineering, where material selection, energy management, and structural design converge to maximize human augmentation, survivability, and combat effectiveness, and reflecting the pre-war military-industrial complex's commitment to pushing technological boundaries even under conditions of extreme secrecy and experimental risk. The engineering of power armor also encompasses the integration of hydraulic servos, actuators, and energy transfer mechanisms that convert fusion core power into usable mechanical force, allowing the wearer to perform feats of strength and endurance far beyond natural human capacity. And the materials used in these systems, high-grade alloys, reinforced composites, and wear-resistant components, ensure durability under sustained stress, prevent structural fatigue, and optimize the transfer of kinetic energy, a synergy between materials science and mechanical engineering that defines the operational capabilities of every suit and underpins the strategic value of powered infantry in pre-war doctrine. Thermal management and environmental protection were also critical engineering considerations, as pre-war designers recognized that extreme temperatures, radiation exposure, and chemical contaminants could compromise both the wearer and the mechanical systems, leading to the integration of heat-resistant alloys, radiation-reflective coatings, and multi-layered filtration systems into the armor's construction, while internal climate control, cooling circuits, and sensor-guided environmental monitoring allowed the wearer to operate in irradiated zones, chemical warfare areas, and extreme climates, without succumbing to environmental hazards, a feature that reinforced the tactical flexibility and survivability of power armor, and ensured that it could serve as both a defensive and operational platform in the most hostile conditions. Modularity in materials and construction was another hallmark of pre-war engineering, allowing damaged panels, joint components, or servos to be replaced, upgraded, or customized according to mission requirements or post-war scavenging opportunities, and this modular philosophy extended to armor plating, internal support structures, helmets, sensory arrays, and integrated weapon mounts, reflecting a systemic approach to maintainability, adaptability, and lifecycle management, while also facilitating post-apocalyptic refurbishment by factions such as the Brotherhood of Steel, who relied on recovered components, technical manuals, and reverse engineering to preserve, enhance, and expand upon pre-war designs, ensuring that power armor remained operational and culturally significant in a resource-scarce, irradiated world. The selection and engineering of armor alloys required a careful balance between hardness, tensile strength, ductility, and weight, ensuring that protective plating could absorb impacts without catastrophic failure, resist penetration, and remain lightweight enough to prevent excessive strain on the servo-mechanical systems and the wearer, while advanced composites and layered designs in later models allowed for distributed stress absorption, energy deflection, and enhanced flexibility, a combination that addressed the operational shortcomings of earlier designs and enabled soldiers to maintain combat readiness across diverse environmental and tactical scenarios. Energy efficiency and power transmission were also tightly coupled with material engineering, as the performance of servos, hydraulic actuators, and auxiliary systems depended on precise conductivity, minimal resistance, and structural integrity under load, with components engineered to dissipate heat, resist wear, and maintain alignment over repeated use, while fusion core integration necessitated specialized materials capable of withstanding high temperatures, radiation flux, and energy surges, ensuring that both the suit and its wearer remained functional under extreme operational conditions, and highlighting the interdependence of material choice, mechanical design, and energy management in pre-war engineering philosophy. Post-war applications of power, armor, materials, and engineering principles illustrate the enduring value of these technologies, as surviving factions salvage alloys, hydraulic components, and structural frameworks to maintain operational suits, fabricate hybrid designs, or repurpose systems for industrial, combat, or survival purposes, demonstrating that the meticulous engineering and material science invested in these suits continues to provide practical and symbolic advantages, shaping factional power dynamics, technological hierarchies, and survival strategies across the wasteland. Ultimately, the materials and engineering of power armor represent a convergence of metallurgical innovation, mechanical design, energy integration, environmental protection, and ergonomic sophistication, a testament to pre-war ambition, technological mastery, and battlefield pragmatism, where every alloy, servo, actuator, and armor panel contributes to the operational effectiveness, survivability, and cultural significance of powered infantry, and where the legacy of these engineering achievements continues to define tactical, social, and symbolic structures in the post-apocalyptic Fallout world, ensuring that power armor remains both a technological marvel and an enduring icon of human resilience, innovation, and adaptation in the irradiated wastelands. Power sources and maintenance represent the lifeblood of power armor functionality in the Fallout universe, forming the critical nexus between mechanical engineering, battlefield performance, and operational longevity. And understanding these systems requires a detailed exploration of both the energy technologies that powered pre-war suits and the rigorous upkeep protocols developed to ensure sustained effectiveness across extended combat operations. At the heart of every powered armor suit lies the fusion core, a compact, high-output energy cell capable of generating immense amounts of electricity necessary to operate hydraulic servos, environmental filtration systems, sensor arrays, heads-up displays, and auxiliary weaponry, with early models such as the T-45 relying on larger, less efficient cores that limited operational duration and required careful monitoring, while subsequent generations like the T-51B, T-60, and X1 integrated smaller, more energy-dense cores with improved thermal management and redundancy systems, allowing for prolonged field operations, higher output demands, and greater survivability under extreme environmental conditions, a critical consideration given the pre-war military emphasis on extended campaigns, mechanized infantry mobility, and survivability in irradiated or chemically hazardous zones. Fusion cores, often produced in specialized military and industrial facilities, represented a sophisticated intersection of nuclear physics, metallurgy, and energy engineering, designed to provide consistent and controllable power output while minimizing the risks of overheating, radiation leakage, or catastrophic failure, and their integration into power armor required precisely engineered energy conduits, power regulators, and safety interlocks to distribute energy efficiently to mechanical, environmental, and electronic subsystems, ensuring that, even under full operational load, the wearer could rely on stable and predictable performance. A technological challenge that underscored both the complexity and fragility of pre-war power armor systems. Maintenance protocols for powered armor were equally rigorous, reflecting the complexity of the suit's mechanical, hydraulic, and electrical systems, with pre-war military manuals specifying regular inspection of hydraulic lines, servo actuators, joint articulations, armor integrity, environmental filtration units, and energy core interfaces, as failure in any subsystem could compromise both operational effectiveness and wearer safety, and trained personnel were required to conduct preventive maintenance, replace worn components, calibrate sensors, and ensure fusion cores were properly seated, cooled, and shielded, creating a disciplined system of upkeep that transformed each armor unit into a reliable and formidable combat asset. Field maintenance was facilitated by modular construction and replaceable components, allowing soldiers to swap damaged armor plates, replace servos, or recalibrate sensors in forward positions or temporary encampments, while more extensive repairs, recalibrations, or energy system overhauls were conducted at specialized depots, workshops, or enclave-controlled facilities, ensuring continuity of operations and long-term serviceability, a practice that became especially critical in post-war recovery scenarios, where salvaged units required careful refurbishment to remain functional, often combining parts from multiple generations of armor to create hybridized systems capable of extended use despite scarcity of original components. Energy monitoring and conservation were also key aspects of maintenance, with fusion core output closely tracked to prevent overload, excessive drain, or premature depletion. while auxiliary power systems could temporarily compensate for partial failures or peak demand, allowing the wearer to maintain operational readiness, mobility, and protection in dynamic battlefield conditions. And these redundancies exemplify the pre-war military focus on reliability, survivability, and tactical flexibility, principles that continued to shape post-apocalyptic use, salvage operations, and factional strategies. Contamination control and filtration system upkeep were critical elements of maintenance, as failure in these subsystems could expose the wearer to lethal radiation, chemical agents, or particulate hazards, and pre-war manuals specified regular inspection, cleaning, and replacement of filters, seals, and ventilation systems, while sensor calibration ensured that environmental hazards were accurately detected and mitigated, reflecting an understanding of the integrated nature of power armor, where mechanical, energy, and environmental systems were interdependent, and any deficiency could compromise both soldier safety and mission success. Mechanical systems, including hydraulic actuators, servo motors, and joint assemblies, required lubrication, stress testing, and alignment to prevent wear, fatigue, or catastrophic failure, with engineers accounting for load distribution, vibration damping, and kinetic energy transfer to optimize performance and prolong lifespan, while advanced materials in later models, such as the T60 and X1, reduced wear rates and improved durability, yet still necessitated regular inspection and preventative maintenance to ensure consistent operational reliability, particularly in high-intensity combat or hazardous environmental conditions. Post-war scavengers, factions, and surviving militarized groups often face the challenge of maintaining power armor in a resource-scarce, irradiated landscape, where replacement parts were rare, fusion cores were scarce, and technical expertise was limited, prompting improvisation, reverse engineering, and hybridization. And in these contexts, knowledge of pre-war maintenance procedures became invaluable, allowing organizations, such as the Brotherhood of Steel, to preserve, refurbish, and enhance suits for both practical and symbolic purposes, ensuring operational continuity while reinforcing hierarchical control through exclusive access to functioning armor. Fusion cores themselves became central to both functionality and status, with pre-war and post-war users understanding that the operational lifespan of a suit was intrinsically tied to the availability, quality, and integrity of these power sources, leading to careful management, secure storage, and judicious allocation in both military doctrine and post-apocalyptic scavenging culture, and emphasizing the strategic value of energy resources as much as the armor itself. Operational failures were mitigated through redundancy, monitoring, and emergency protocols, including automated alerts for overheating, pressure anomalies, servo malfunctions, and energy fluctuations, while self-limiting subsystems could prioritize critical functions over auxiliary systems in cases of partial energy depletion, allowing the wearer to maintain essential mobility, protection, and life support even under adverse conditions. And these features highlight the sophisticated integration of energy, mechanics, and human factors engineering in pre-war designs. Culturally, the emphasis on power sources and maintenance reflects the broader pre-war ethos of technological mastery, precision, and preparedness, with the functionality of each armor suit contingent not only on advanced materials and mechanical design, but also on meticulous upkeep, energy management, and procedural discipline, creating a technological ecosystem in which survival, combat effectiveness, and strategic advantage were inseparable from knowledge, training, and maintenance practice. Ultimately, the power sources and maintenance protocols of power armor illustrate the interdependence of energy generation, mechanical performance, environmental protection, and operational readiness, demonstrating how pre-war engineers, soldiers, and industrial planners meticulously balanced energy, density, mechanical reliability, and system sustainability to create wearable platforms capable of transforming human capability, surviving extreme conditions, and asserting dominance on the battlefield. And the continued importance of these systems in post-apocalyptic recovery, refurbishment, and factional control underscores the enduring legacy of pre-war engineering, cementing power armor as not merely a technological artifact, but a dynamic system whose operation, upkeep, and energy management define survival, authority, and tactical supremacy in the Fallout universe. The cultural impact of power armor in the wasteland extends far beyond its practical military utility, representing a complex interplay of symbolism, authority, fear, and identity that shapes post-apocalyptic society across the Fallout universe, and its influence can be traced to both pre-war propaganda and post-war mythology, where the image of a soldier clad in advanced, fully integrated combat exoskeleton conveys not only technological mastery, but also dominance, survival, and control over scarce resources, creating a visual and psychological shorthand for power that resonates deeply with both factions and individual survivors. In the immediate aftermath of the Great War, power armor became an emblem of pre-war authority and technological superiority, with intact suits, salvageable components, and functional units representing tangible links to the lost civilization, and their presence could confer legitimacy to groups seeking to assert dominance, establish territorial control, or inspire obedience among followers, while also serving as a deterrent to rival factions and opportunistic raiders, who recognized that the wearer possessed both superior protection and the capacity for lethal force, a combination that could turn the tide in any encounter. The legendary status of power armor is amplified by its scarcity, complexity, and the difficulties inherent in maintaining and operating the suits, as functional suits require fusion cores, skilled technicians, and an understanding of pre-war mechanics, all of which are rare commodities in the irradiated wasteland, and these logistical barriers elevate power armor from a mere combat tool to a symbol of elite status, wealth, and technical sophistication, with factions like the Brotherhood of Steel, the Enclave, and opportunistic mercenary groups often monopolizing suits to assert social and military authority, create hierarchical structures, and control access to critical technology, embedding the armor deeply into the political and cultural landscape of post-apocalyptic America. Within factional societies, power armor functions as a visible marker of legitimacy and rank, with heavily armored soldiers or officers signaling the presence of authority, discipline, and capability. And the psychological impact of this cannot be overstated, as wasteland populations, including independent settlements, scavengers, and raider gangs, often respond with fear, reverence, or compliance when confronted with the imposing silhouette of a fully armored individual, a phenomenon that extends from the pre-war military training doctrine of intimidation and psychological advantage, demonstrating the continuity of symbolic power even in the fractured, chaotic post-war environment. Popular lore and myth-making surrounding power armor further reinforce its cultural resonance, with stories, rumors, and propaganda depicting legendary warriors, heroic defenders, or feared enforcers in iconic suits, including T-51B veterans of pre-war conflicts, T-60 Enclave agents, and experimental X-1 prototypes, creating a mythos that intertwines technological achievement, moral authority, and narrative identity. And these stories circulate widely among wasteland communities, shaping perceptions of risk, respect, and opportunity, while simultaneously inspiring scavengers, adventurers, and aspiring warriors to seek out, recover, or emulate the suits in hopes of attaining similar power and recognition. The aesthetic and symbolic design of power armor also contributes to its cultural significance, as the imposing silhouette, reinforced plating, helmeted visage, and mechanical articulation evoke imagery of invincibility, mechanized authority, and inhuman capability, creating a psychological impact that often precedes direct engagement and influencing both narrative storytelling and tactical behavior in the wasteland, with armored figures frequently functioning as both real and symbolic enforcers of factional dominance. The socio-political ramifications of power armor in the wasteland extend to the organization of factions, as the possession and operation of these suits allow groups to establish a monopoly on technological authority, enforce territorial boundaries, and dictate resource allocation, while simultaneously reinforcing internal hierarchies, where the most skilled, loyal, or trusted members gain access to the most advanced armor, thereby intertwining technological capability with social structure, leadership legitimacy, and operational effectiveness, a dynamic vividly illustrated in the practices of the Brotherhood of Steel, who maintain strict custodianship over armor and technology to preserve both material and symbolic dominance. Post-war scavengers and independent operators also participate in the cultural mythology of power armor, as recovered suits become the focus of ambition, status, and identity, transforming the wearer into an object of fascination, fear, or envy, and creating narratives of heroism, ingenuity, or notoriety that persist in local oral histories, journals, or community storytelling, illustrating the enduring role of power armor in shaping individual identity, social interaction, and myth-making across the wasteland, while simultaneously providing functional advantages that reinforce the perception of power. Power armor also intersects with technological fetishization in wasteland culture, as the armor embodies the lost knowledge, industrial capacity, and scientific sophistication of pre-war society, becoming a symbol of human ingenuity, perseverance, and the potential for control over one's environment, and this cultural dimension is reinforced by factions, scholars, and scavengers who seek to study, replicate, or adapt these suits, creating an intellectual and symbolic engagement with technology that mirrors the material and tactical applications of the armor itself, and contributing to the construction of a technological mythos that defines the wasteland's understanding of power, authority, and survival. The visual prominence and psychological impact of armored figures also shape interactions between factions and settlements, as the mere presence of a power armor-clad individual can deter aggression, command respect, or provoke negotiation, and this phenomenon reinforces the armor's role as both a practical and symbolic instrument of control, demonstrating that the cultural influence of power armor is inseparable from its operational capabilities, with utility and mythos mutually reinforcing one another in shaping wasteland dynamics. Ceremonial, ritualistic, and symbolic uses of power armor further illustrate its cultural impact, with factions such as the Brotherhood of Steel incorporating suits into rites of passage, demonstrations of rank, or public displays of technological mastery, emphasizing the intersection of martial capability, technical knowledge, and social authority, and reinforcing the narrative of continuity with pre-war ideals of discipline, honor, and mastery over technology, while simultaneously instilling awe, fear, and respect among observers, a phenomenon echoed in the popular imagination through stories of legendary armored warriors, battlefield heroes, and enforcers of justice or tyranny. In addition to their symbolic and social functions, power armor suits serve as tools of narrative construction, providing tangible anchors for stories of survival, conquest, and moral choices, with individual suits often acquiring reputations tied to their wearers' deeds, whether heroic, infamous, or enigmatic. And these reputations propagate across communities, inspiring emulation, cautionary tales, and strategic calculation, reinforcing the armor's role in shaping not only physical outcomes, but also cultural narratives, communal memory, and identity formation. In the post-apocalyptic environment, the cultural impact of power armor is also evident in its influence on art, media, and architecture within the wasteland, as depictions of armored figures appear in murals, graffiti, effigies, and commemorative installations, reflecting admiration, fear, or ideological alignment, and these representations function as both mnemonic devices and instruments of social cohesion or intimidation, embedding the imagery and symbolism of armored power into the daily lives, beliefs, and perceptions of wasteland inhabitants, a phenomenon that perpetuates the authority of factions and the mystique of legendary suits. Technologically, the complexity of power armor reinforces the cultural hierarchy, as access, knowledge, and operational competence are highly valued, creating a social stratification where those capable of operating or maintaining suits gain both functional advantage and elevated status, and this dynamic informs recruitment, loyalty, and the perpetuation of organizational structures, with armor becoming an instrument of both practical command and symbolic prestige, while simultaneously inspiring aspirants, scavengers, and competitors to seek mastery of the technology. Ultimately, the cultural impact of power armor in the wasteland is inseparable from its operational, symbolic, and historical dimensions, as each suit functions simultaneously as a weapon, protective system, status symbol, and narrative artifact, shaping social hierarchies, factional power, personal identity, and myth-making, while reinforcing the intertwined relationship between technology, authority, and survival in a world where scarcity, danger, and legend define human experience, ensuring that power armor remains both a practical tool of dominance and a profound cultural icon within the Fallout universe, influencing behavior, belief systems, and intergroup dynamics across generations of wasteland inhabitants. The Brotherhood of Steel, established in the aftermath of the Great War, embodies the custodian role for pre-war technology, with power armor serving as the cornerstone of their identity, operational capability, and ideological framework, and understanding their relationship with these suits requires examining the historical, tactical, and cultural dimensions that underpin their stewardship, as well as the organizational structures and philosophies that dictate how power armor is preserved, enhanced, and monopolized within their ranks. Emerging from the ruins of California under the leadership of Roger Maxson, the Brotherhood adopted a militarized, quasi-religious framework in which technology is sacred, and the recovery, maintenance, and use of power armor is both a practical necessity and a symbolic assertion of authority over knowledge and power, establishing a doctrine in which armor is never merely a tool but a manifestation of human ingenuity and pre-war civilization, and access to these suits is strictly regulated to maintain the integrity of their technological monopoly and reinforce hierarchical command structures. The Brotherhood's custodianship of power armor involves meticulous collection, cataloging, and preservation of intact suits, salvaged components, and operational manuals, with specialized workshops, armories, and armorer divisions dedicated to the inspection, repair, and upgrading of armor, reflecting a systemic approach to technological management that prioritizes both functionality and long-term survivability, and ensuring that their soldiers operate with the most advanced, well-maintained equipment available, a practice that has allowed the Brotherhood to maintain tactical superiority over wasteland factions and independent operators despite scarcity of materials and energy resources. The preservation process involves not only mechanical repair, but also the careful management of fusion cores, hydraulic servos, and environmental filtration systems, as functional power armor requires continuous energy, maintenance expertise, and component integrity, and the Brotherhood invests heavily in training and knowledge retention to guarantee that both the armor and the associated technological know-how are passed from generation to generation, creating a continuity of operational capability and cultural identity that reinforces the centrality of power armor to their mission and worldview. In addition to preservation, the Brotherhood actively enhances and modifies power armor, integrating recovered technology, experimental components, and hybridized systems to improve performance, durability, and versatility, with upgrades often tailored to specific combat roles, environmental conditions, or strategic objectives, reflecting a philosophy that combines reverence for pre-war designs with pragmatic innovation, ensuring that each iteration of armor not only survives, but evolves to meet the challenges of post-apocalyptic warfare and exploration, a principle that has enabled the Brotherhood to maintain relevance across decades of environmental, social, and political upheaval. Access to power armor within the Brotherhood is tightly controlled, governed by rank, training, and demonstrated loyalty, with higher-ranking members often receiving the most advanced or specialized suits, while new recruits or lower-ranking soldiers are initially equipped with standard models such as T-51B or refurbished T-60 units, a system that enforces internal hierarchy, preserves operational security, and cultivates respect for technological stewardship, and reinforces the ideological notion that power armor is both a privilege and a responsibility, requiring disciplined use and reverent treatment in accordance with the Brotherhood's ethical and tactical codes. The Brotherhood also uses power armor as a symbolic tool, presenting armored soldiers during ceremonies, patrols, and displays to project authority, reinforce social cohesion, and assert dominance over contested territories, settlements, and rival factions, creating a psychological impact that extends beyond tactical utility and into cultural influence, as the sight of fully armored knights or paladins can inspire loyalty, fear, or submission among wasteland inhabitants, perpetuating the image of technological mastery and martial prowess, and embedding power armor into the social fabric of the Brotherhood's interactions with the wider world. Factional doctrine emphasizes the strategic collection of armor and components from irradiated zones, former military facilities, and battlefield wreckage, with Brotherhood expeditions focused not only on immediate tactical acquisition, but also on the long-term preservation and integration of pre-war technology into their inventory, ensuring that knowledge, materials, and operational capability are retained even in the face of environmental degradation, enemy action, or internal attrition, a practice that has allowed the Brotherhood to maintain technological continuity and operational dominance where other groups have faltered. The ethical and ideological dimensions of custodianship also inform the Brotherhood's interactions with outsiders, as access to power armor is rarely extended beyond the Order, and attempts by independent scavengers, mercenaries, or other factions to seize or operate these suits are met with resistance, negotiation, or enforcement, reflecting a belief that the preservation of advanced technology is inseparable from the stability, security, and identity of the Brotherhood, and that misuse by untrained or morally unaligned individuals could result in catastrophic consequences, both practical and symbolic. Beyond operational and ideological considerations, the Brotherhood maintains detailed archives documenting the history, specifications, and operational protocols of power armor, ensuring that each suit's provenance, modifications, and deployment history are meticulously recorded, a practice that enables not only maintenance and upgrades, but also strategic planning, research, and historical continuity, reinforcing the notion that power armor is simultaneously a functional asset, a repository of knowledge, and a cultural artifact, central to both the martial and intellectual life of the Order. In combat, Brotherhood power armor is employed with precision and discipline, reflecting a combination of advanced training, tactical doctrine, and technological supremacy, with armored units performing high-risk operations, enforcing territorial control, and acting as rapid response or heavy assault forces, demonstrating how custodianship extends beyond passive preservation to active, strategic application, allowing the Brotherhood to project power, maintain internal cohesion, and assert dominance over both allies and adversaries in the wasteland. The interplay between technological mastery and ritualistic reverence is also evident in the ceremonial aspects of power armor use, where suits are displayed, inspected, and presented in ways that reinforce ideological narratives of human ingenuity, stewardship, and the sanctity of technology, creating a cultural ecosystem in which armor functions as both a practical tool of survival and combat and a tangible representation of moral, historical, and intellectual authority, shaping the identity, perception, and behavior of Brotherhood members, as well as external observers. Post-war adaptations of custodianship further highlight the Brotherhood's role in maintaining technological continuity, as recovered suits from T-45, T-51, T-60, and even X-1 models are repaired, upgraded, and integrated into operational units, preserving pre-war capabilities while enhancing them with wasteland innovations, a process that requires specialized technical knowledge, disciplined organization, and a commitment to the careful balancing of tradition and innovation, ensuring that power armor remains both functional and emblematic of the Order's mission. Ultimately, the Brotherhood of Steel's custodianship of power armor represents a multifaceted approach to technology that integrates preservation, enhancement, control, symbolism, and tactical application, creating a model in which armor functions as a material, operational, and cultural axis of power, authority, and identity, shaping not only military outcomes but also social hierarchies, ideological cohesion, and historical memory, ensuring that in the fractured, resource-scarce, and dangerous wasteland, power armor remains both a formidable tool and a profound symbol of the enduring legacy of pre-war technological mastery, human resilience, and disciplined stewardship, and that the Brotherhood's role as custodian continues to define the interplay between technology, power, and culture across the Fallout universe. Faction-specific variants of power armor in the Fallout universe reflect the ingenuity, adaptation, and strategic priorities of post-war groups, with each faction modifying pre-war designs to suit their unique operational requirements, ideological principles, and available resources, demonstrating how the technology of pre-war America evolved into a tool of survival, power projection, and cultural identity in the fractured wasteland. The New California Republic, NCR, inheriting remnants of pre-war military stockpiles and industrial capacity, primarily adopted the T-51B and later T-60 models, implementing modifications to improve maintainability, environmental adaptability, and logistical compatibility with their conventional military units, with armor often painted in muted, utilitarian schemes that reinforced the NCR's identity as a disciplined, quasi-democratic force, and upgrades focused on maximizing durability, mobility, and integration with standard-issue weaponry to support large-scale deployments across the varied terrains of California and beyond, demonstrating the NCR's pragmatic approach to technological adaptation in a politically and militarily complex wasteland. The Enclave, as the direct continuation of the pre-war United States government, leveraged both advanced technological knowledge and experimental resources to create highly specialized variants, including heavily fortified T-51B suits, the T-60 for operational deployment, and the X-1 series for elite forces, incorporating enhancements in armor plating, energy shielding, sensor suites, and fusion core efficiency, reflecting a philosophy that prioritizes absolute battlefield superiority, psychological intimidation, and centralized control over recovered technology, with operational doctrine emphasizing elite, technologically dominant units capable of enforcing Enclave authority, conducting targeted operations, and projecting the mythos of pre-war government supremacy in the wasteland, and their variant designs often display sleek, imposing aesthetics, including polished black finishes and symbolic insignia, reinforcing both tactical and ideological presence. Raider factions, opportunistic and resourceful, often produce improvised or hybridized variants by scavenging armor components from pre-war stockpiles, abandoned military depots, or battlefield wreckage, incorporating mismatched plates, reinforced joints, and repurposed servos to create functional, if aesthetically chaotic, suits, prioritizing intimidation, resilience, and offensive capability over precise engineering, with modifications reflecting immediate necessity rather than systematic design, yet producing effective combat platforms that enhance survivability and project dominance within localized territories, demonstrating how even fragmented knowledge and limited materials can transform pre-war power armor into a versatile instrument of authority and survival in the anarchic post-war environment. The Brotherhood of Steel, distinct from other factions, emphasizes the preservation, enhancement, and disciplined deployment of standardized pre-war models, yet also produces faction-specific variants through systematic upgrades, hybridization, and tactical customization, with differences in plating, servo calibration, and environmental systems reflecting operational theater, mission profile, and internal rank, creating a hierarchy of suits that simultaneously maintains technological fidelity, reinforces authority, and preserves the ideological sanctity of pre-war engineering while adapting to post-war realities. And these variants often serve as benchmarks for other factions seeking to understand or emulate advanced armor technology. Modifications across factions also reflect environmental adaptation, with desert-oriented suits incorporating heat-resistant alloys, improved cooling systems, and dust filtration, while northern or irradiated region variants emphasize enhanced radiation shielding, joint protection, and fusion core longevity, demonstrating a sophisticated understanding among wasteland factions of how pre-war designs could be optimized to survive diverse and hostile environments, and highlighting the interplay between technological preservation and situational pragmatism. Weapon integration varies between factions as well, with the NCR favoring conventional ballistic support, modular mounts, and compatibility with standard rifles and heavy weapons, while the Enclave integrates energy weapons, stabilizing systems, and auxiliary targeting arrays, reflecting both doctrinal preference and access to advanced pre-war research. And Raider modifications often incorporate jury-rigged stabilizers or improvised mounts, emphasizing aggression and intimidation over technical sophistication, revealing the degree to which factional priorities shape mechanical adaptation, operational philosophy, and battlefield application. The Enclave's X1 variants are particularly notable for their experimental enhancements, including reinforced servo mechanics, advanced HUD systems, and integrated environmental sensors designed for high-risk, high-value operations, reconnaissance, or elite assault, showcasing the faction's willingness to push the limits of pre-war technology in pursuit of dominance, while ensuring operational secrecy and exclusivity, a practice that consolidates both tactical and symbolic authority, with the suits themselves becoming a tool of narrative power, myth-making, and psychological leverage. The aesthetic differentiation of faction-specific variants also serves symbolic, ideological, and psychological purposes, as color schemes, insignia, and customized plating convey rank, allegiance, and operational intent, with black and gold Enclave X, one projecting authoritarian supremacy, olive-toned NCR T51B and T60 reinforcing disciplined professionalism, and chaotic, patchwork, Raider suits communicating unpredictability and raw aggression, creating a visual language that conveys identity, authority, and intent even before engagement, and influencing both internal morale and external perception in contested wasteland territories. Maintenance practices for faction-specific variants reflect operational philosophy, available resources, and technical knowledge, with the NCR implementing standardized workshops and repair chains to support field units, the Enclave employing highly controlled, centralized depots with strict procedural oversight, and Raiders relying on scavenged materials, improvisation, and individual ingenuity to keep their hybridized suits operational, demonstrating how factional priorities shape not only design and deployment, but also the practical lifecycle management of armored units. In addition to operational adaptation, faction-specific variants influence tactical doctrine, with armor enhancing small unit tactics, fortification defense, and offensive operations, allowing each faction to exploit the strengths of their unique suits. The NCR integrates armor into coordinated military formations, emphasizing massed firepower and disciplined maneuver. The Enclave uses elite armored squads for surgical strikes, intimidation, and control, while raiders rely on shock, mobility, and fear projection, demonstrating how pre-war technology is repurposed to meet the strategic needs and cultural identity of each post-war faction. The social and cultural significance of faction-specific power armor cannot be overstated, as access to these suits communicates authority, instills loyalty, and enforces hierarchy within each group, creating a direct link between technological capability and social structure, with specialized variants serving as symbols of elite status, technical mastery, and operational competence, while simultaneously reinforcing the faction's mythos, legacy, and perceived legitimacy. Embedding power armor deeply into both practical and symbolic dimensions of post-war society, interactions between factions often center on control, acquisition, and competition over advanced variants, with recoverable T-51B, T-60, and X-1 models representing both strategic assets and cultural trophies, fueling conflict, diplomacy, and negotiation, while driving technological transfer, reverse engineering, and hybridization among competing groups, illustrating how faction-specific variants extend beyond combat effectiveness to shape the political, cultural, and technological dynamics of the wasteland. Ultimately, faction-specific variants of power armor illustrate the post-apocalyptic evolution of pre-war technology, demonstrating how design, maintenance, adaptation, aesthetics, and operational doctrine converge to create suits that reflect the identity, priorities, and capabilities of the groups that wield them, while simultaneously influencing social hierarchy, psychological impact, myth-making, and tactical outcomes, ensuring that power armor remains a defining element of factional power, cultural identity, and survival strategy in the Fallout universe, and highlighting the enduring legacy of pre-war innovation as it continues to shape the organization, operation, and symbolic authority of post-war societies across the wasteland. The combat applications of power armor in the Fallout universe represent a transformative evolution in post-apocalyptic warfare, fundamentally altering the dynamics of survivability, firepower, mobility, and tactical doctrine, with pre-war engineering designed to enhance human capability to levels previously achievable only by mechanized units or vehicles, and post-war adaptation, ensuring that these advantages continue to define military and factional operations across the irradiated wasteland. Power armor allows the wearer to sustain combat operations far beyond normal human limits, combining hydraulic-assisted strength, augmentation, reinforced exoskeletal structures, and energy-efficient servomechanics to enable the lifting and carrying of heavy weaponry, the traversal of hazardous terrain, and the execution of physically demanding maneuvers that would otherwise incapacitate or endanger unarmored soldiers. And this mechanical augmentation multiplies both offensive and defensive effectiveness, turning individual combatants into mobile force multipliers, capable of performing tasks traditionally requiring entire squads, demonstrating the direct correlation between armor technology and battlefield dominance. The integration of environmental protection, including radiation shielding, chemical filtration, and temperature regulation, further expands the tactical envelope of combat operations, allowing power armor-clad soldiers to operate in irradiated zones, chemically contaminated areas, and extreme climates without the limitations imposed on conventional infantry, effectively creating a class of soldiers who can perform reconnaissance, assault, and defensive operations in environments that would be inaccessible to ordinary forces, while simultaneously providing an enduring psychological advantage over adversaries who perceive the armored combatants as nearly invincible. Combining practical survivability with battlefield intimidation, the enhanced mobility afforded by servo-mechanical actuators and hydraulic systems ensures that power armor users can maintain speed, agility, and precision under extreme load, facilitating rapid deployment, flanking maneuvers, vertical navigation of structures, and sustained movement under fire, allowing commanders to design and execute complex tactical strategies that exploit both the mechanical and psychological advantages of armored units and enabling scenarios such as breaching fortified positions, executing shock assaults, or providing rapid extraction and support under fire, where conventional forces would be unable to respond effectively. Offensive capabilities are similarly augmented through the integration of heavy weapon compatibility, recoil stabilization, and precision targeting, allowing wearers to employ energy weapons, high-caliber firearms, and heavy ordnance with increased accuracy and reduced physical strain, converting individual soldiers into highly effective weapons. Platforms capable of delivering sustained firepower while maintaining operational endurance, and this technological force multiplication reshapes the balance of power in both pre-war and post-war conflicts, with armored units frequently serving as decisive elements in skirmishes, territorial control, and strategic campaigns. The presence of power armor also alters unit composition and tactical doctrine, as commanders can deploy smaller, highly capable teams to achieve objectives traditionally requiring larger formations, emphasizing mobility, concentrated firepower, and technological superiority over numerical strength, a shift that continues into post-war factional strategies, with organizations such as the Brotherhood of Steel, the Enclave, and the NCR, relying on armored squads to perform high-risk operations, enforce territorial dominance, and maintain operational superiority in engagements with raiders, rival factions, or hostile wildlife, illustrating the enduring relevance of pre-war combat engineering in shaping post-apocalyptic warfare. Defensive applications of power armor include ballistic resistance, impact absorption, energy dissipation, and environmental protection, allowing soldiers to withstand conventional firearms, explosives, energy weapons, and environmental hazards that would incapacitate unarmored personnel, thereby redefining survivability metrics on the battlefield and enabling more aggressive, risk-tolerant operational strategies, while simultaneously reinforcing morale, confidence, and psychological dominance, both within units and in adversary assessments, emphasizing the dual role of armor as both practical protection and symbolic assertion of combat superiority. Integrated sensor suites, HUD displays, and tactical communication systems enhance situational awareness, target identification, and coordination, enabling power armor users to process battlefield information in real time, communicate with command elements or squad members, and adapt rapidly to evolving threats, effectively integrating intelligence, reconnaissance, and combat execution into a single operational platform, and creating opportunities for decentralized, autonomous decision-making in small units while maintaining cohesion and operational alignment with larger strategic objectives. The modularity of power armor further supports combat versatility, allowing field repairs, component upgrades, and mission-specific adaptations, such as additional armor plating, sensor enhancements, or integrated weapon mounts, enabling soldiers to tailor their suits for particular operational environments, threat types, or tactical roles, and ensuring that armored units remain resilient, adaptable, and effective even in extended campaigns or resource-scarce contexts where conventional logistics are unavailable, demonstrating a synthesis of technological flexibility and tactical foresight. Psychological warfare is another dimension of combat application, as the sight of power armor can demoralize enemy forces, project authority, and reinforce factional dominance, leveraging the cultural and mythological weight of armor to complement practical combat advantages, with heavily armored units often serving as focal points of fear, propaganda, or coercion, and influencing enemy behavior before engagement, while enhancing the confidence and cohesion of allied units, creating a force multiplier effect that extends beyond mere physical performance into strategic influence. Faction-specific adaptations of combat armor highlight variations in doctrine, operational priorities, and resource availability, with the NCR favoring coordinated massed formations with standard-issue T-51B or T-60 units to enforce structured tactical operations, the Enclave employing advanced X-1 variants for elite strikes, and surgical engagement with maximum technological advantage, and raiders or opportunistic groups improvising hybridized suits to maximize intimidation and short-term combat effectiveness, illustrating how pre-war designs can be repurposed to reflect post-war realities, strategic priorities, and environmental constraints, while retaining core combat-enhancing properties. The endurance and sustainability of power armor in combat are also critical, with fusion core management, hydraulic system reliability, and joint integrity dictating operational duration, while field maintenance practices such as component swaps, actuator calibration, and sensor realignment ensure continuous functionality in prolonged engagements, emphasizing the logistical and technical skills required to maintain combat readiness and highlighting the interdependence of technology, training, and tactical planning. Urban, rural, and irradiated combat environments further demonstrate the versatility of armored units, as modular suits can navigate collapsed structures, contaminated zones, and rugged terrain, allowing commanders to exploit mobility, protection, and firepower in unconventional or asymmetric engagements, expanding the tactical repertoire available to factions capable of fielding functional armor and creating a distinct disparity between armored and unarmored forces in both pre-war and post-war contexts. The synergy between human decision-making and mechanical augmentation allows power armor users to execute maneuvers that blend instinct, strategy, and enhanced capability, transforming individuals into dynamic, responsive combatants capable of adapting to shifting threats, coordinating with allied units, and leveraging environmental advantages, embodying a form of mechanized combat evolution where technology extends the natural limits of human performance while preserving cognitive and tactical agency. Training, doctrine, and operational procedures are integral to maximizing combat applications, with successful utilization of power armor requiring mastery of movement, energy management, weapon integration, situational awareness, and repair protocols, ensuring that armored units achieve both individual and collective efficiency, while mitigating risks associated with system failures, overextension, or environmental hazards. reinforcing the critical interplay between technological proficiency, discipline, and tactical success. Post-apocalyptic combat scenarios, including factional warfare, raider incursions, and exploration of irradiated or hazardous regions, highlight the continued strategic value of power armor, with functional suits determining the outcome of engagements, shaping territorial control and influencing factional hierarchies, while simultaneously preserving the legacy of pre-war engineering, innovation, and its enduring relevance in defining the capabilities, survivability, and authority of armored forces in a technologically regressed yet resourceful wasteland. Ultimately, the combat applications of power armor encompass a multidimensional spectrum of survivability, firepower, mobility, psychological influence, tactical innovation, and strategic flexibility, illustrating how these exoskeletal systems redefine warfare, operational doctrine, and human potential in both pre-war and post-apocalyptic contexts, while maintaining cultural, symbolic, and technological significance across generations, establishing power armor as an indispensable instrument of combat efficacy, social influence, and factional dominance within the Fallout universe. Iconic suits and legendary units in the Fallout universe occupy a unique place at the intersection of technological achievement, historical narrative, and cultural mythos, serving as tangible symbols of power, skill, and survival, while shaping the collective memory and identity of factions, settlements, and individual survivors in the post-apocalyptic wasteland. And understanding their significance requires examining both the mechanical uniqueness of specific suits and the historical deeds of the individuals who wore them, as well as the ways in which these suits became embedded in the lore, propaganda, and legend of the Fallout world. Among the earliest iconic designs is the T-45 series, which, while mechanically rudimentary by later standards, achieved notoriety due to its widespread deployment in pre-war conflicts, the decisive engagements of the Resource Wars, and its status as the first operationally deployed powered exoskeleton, with surviving units preserved or salvaged by factions such as the Brotherhood of Steel, whose careful maintenance and ceremonial use transformed these suits from obsolete tools into revered artifacts representing the dawn of mechanized personal armor, a narrative that intertwines technological innovation with historical continuity. The T-51B series, by contrast, achieved legendary status both for its mechanical superiority and its pervasive role during and after the Great War, with its advanced alloys, improved servo mechanics, and integration of environmental protection systems, making it the armor of choice for elite pre-war military units, and post-war recoveries by the Brotherhood, Enclave, and scavenger groups further enhanced its prominence, as individual suits became associated with heroic, notorious, or enigmatic figures whose deeds in combat, exploration, or survival elevated the suits to mythic stature, creating stories that persist in wasteland oral histories, factional records, and survivor accounts. The T-60 series also occupies a notable place in the annals of legendary units, particularly due to its late pre-war design improvements and post-war operational deployment by both the NCR and the Brotherhood of Steel, with variants featuring reinforced plating, optimized hydraulic systems, and modular design enhancements that allowed them to survive prolonged combat operations, environmental hazards, and scavenger modifications, and individual T-60 units associated with elite soldiers or decisive engagements became celebrated symbols of resilience, tactical brilliance, and factional identity, reinforcing the interplay between mechanical performance and narrative significance. The X-1 power armor, as the pinnacle of pre-war experimentation, represents perhaps the most storied and iconic of all suits, with prototypes and operational units shrouded in secrecy, restricted to top-tier Enclave operatives or experimental testbeds, featuring cutting-edge alloys, energy absorption systems, advanced HUD integration, and servo-mechanical refinements, and the combination of extreme rarity, superior performance, and association with elite operatives ensured that each X-1 suit became a legend in its own right, inspiring both awe and fear among wasteland denizens and serving as a benchmark against which all other armored units are measured, with stories of these suits often blending documented operational success with exaggeration, myth-making, and factional propaganda. Individual legendary units are often defined not merely by their mechanical specifications, but by the actions of their wearers, creating narratives that fuse human agency with technological performance, such as T-51B suits worn by pre-war soldiers who survived critical engagements, T-60 units employed by Brotherhood knights in pivotal battles, or X-1 suits piloted by elite Enclave operatives during high-risk missions. And these narratives transform the armor into characters in their own right, imbuing them with symbolic power, cultural resonance, and enduring influence over factional lore and wasteland storytelling. The preservation and veneration of iconic suits also underscores the cultural and psychological dimensions of these legendary units, with factions like the Brotherhood of Steel dedicating resources to the meticulous restoration, cataloging, and ceremonial display of notable armor, while survivors and scavengers treat recovered suits as prizes, status symbols, or talismans of survival, reinforcing the idea that legendary armor functions as both a practical tool and a conduit for narrative continuity, identity formation, and mythic authority. In a world where material scarcity amplifies the symbolic weight of technological artifacts, battlefield outcomes further reinforce the iconic status of certain suits as specific units become associated with turning points in factional conflicts, heroic defenses, or high-profile raids, with the armor itself embodying the traits of the wearer: courage, skill, cunning, or ruthlessness, while demonstrating the practical advantages of pre-war engineering, including enhanced survivability, firepower, mobility, and operational adaptability, a fusion that solidifies the legendary reputation of the suit in both factual and folkloric accounts. Environmental adaptability and mechanical resilience also contribute to the status of legendary units, with certain suits surviving extreme radiation, chemical contamination, urban ruin, or irradiated wastelands where ordinary forces would perish, demonstrating the practical superiority of advanced designs while creating narratives of near-mythical endurance, further elevating the status of the armor and its associated figures, and inspiring scavengers, mercenaries, and faction members to seek, emulate, or study these units in hopes of replicating their success. Factional legends reinforce the significance of iconic suits, with the Enclave documenting the operational achievements of X-1 prototypes, the NCR commemorating elite T-51B or T-60 soldiers in battle accounts and ceremonial displays, and the Brotherhood of Steel integrating historical and legendary units into training, recruitment, and internal propaganda, creating a network of narratives that intertwine armor, action, and cultural meaning, ensuring that the legendary status of these suits transcends mere mechanical performance and becomes central to factional identity, cohesion, and legitimacy. Modifications and hybridizations of legendary units also play a role in their status, as recovered suits are upgraded, repaired, or combined with components from multiple generations, extending operational life, enhancing performance, or creating unique variants whose rarity and efficacy further cement their iconic nature. And these adaptations illustrate both the enduring utility of pre-war designs and the creativity of post-war engineers, scavengers, and factional technicians in preserving and enhancing legendary technology under resource-limited conditions. Psychological impact, both on allies and adversaries, remains a defining element of legendary suits, with the visual dominance, imposing silhouette, and documented capabilities of these units influencing tactical behavior, morale, and engagement strategies, as the presence of a known legendary suit on the battlefield can alter enemy decisions, inspire loyalty among allies, and reinforce the perception of technological supremacy, demonstrating the inseparable link between mechanical performance, cultural narrative, and operational psychology. Training, skill, and operational doctrine intersect with the legendary status of armor, as wearers capable of maximizing the capabilities of advanced or rare suits contribute directly to the mythos surrounding the unit, and the combination of human and technological excellence ensures that legends are perpetuated both in material function and narrative form, reinforcing the role of iconic suits as symbols of elite, competence, survival, and strategic dominance. Ultimately, iconic suits and legendary units exemplify the convergence of mechanical innovation, historical consequence, cultural significance, and narrative power, demonstrating that power armor in the Fallout universe is more than a tool of war. It is a repository of memory, a symbol of authority, a benchmark of technological mastery, and a catalyst for myth-making, shaping tactical, social, and cultural landscapes across generations of wasteland survivors, and ensuring that these suits remain enduring icons whose practical, symbolic, and legendary significance continues to influence both individual behavior and factional identity throughout the post-apocalyptic world. Despite their formidable capabilities, power armor in the Fallout universe is not without inherent dangers and limitations, and understanding these vulnerabilities is essential for appreciating both the operational constraints faced by pre-war soldiers and post-war users, and the ways in which factions, scavengers, and adventurers mitigate or exploit these risks, as the very systems that provide enhanced protection, mobility, and firepower introduce dependencies, maintenance challenges, and situational vulnerabilities that can compromise performance, survivability, and tactical effectiveness if mismanaged. One of the most critical dangers associated with power armor is the dependence on fusion cores, compact, high-output energy sources that provide the electricity necessary to power servomechanics, hydraulic actuators, environmental filtration systems, and auxiliary components, and while these cores allow sustained operation far beyond normal human limits, they are finite, subject to rapid depletion under heavy load, and susceptible to damage or leakage, creating a scenario in which the loss or malfunction of a fusion core can immobilize the wearer, shut down life support systems, and render the armor ineffective or even hazardous in combat or hazardous environments. Overheating and thermal management are additional limitations, as the armor's internal systems generate significant heat during extended operations, particularly when operating hydraulic and servo-mechanical systems under maximum load, and failures in cooling systems, blocked ventilation, or damaged heat sinks can lead to internal temperatures that pose severe risk of burns, mechanical seizure, or systemic shutdown, forcing operators to carefully monitor thermal output and implement field cooling or operational pauses to avoid catastrophic failure, highlighting the fine balance between performance and safety inherent in advanced exoskeletal designs. Mobility, while vastly enhanced compared to unarmored soldiers, is constrained by the weight, joint articulation limits, and mechanical tolerances of each suit, with older models such as the T-45 exhibiting lower maneuverability and higher susceptibility to terrain impediments, and even advanced models like the T-60 or X-1 requiring careful coordination to navigate narrow passages, stairways, or uneven terrain, making armored users vulnerable in environments that compromise mobility, emphasizing the importance of environmental assessment and tactical planning when deploying power armor in diverse wasteland conditions. The complexity and integration of mechanical, electronic, and environmental systems introduce significant maintenance and repair challenges, as even minor component failures, such as a servo misalignment, joint actuator wear, sensor malfunction, or environmental filtration blockage, can degrade performance or compromise safety. And in post-war contexts, scarcity of replacement parts, skilled technicians, and fusion cores exacerbates these risks, creating scenarios where armor becomes unreliable, partially functional, or dangerously compromised, demonstrating that operational excellence is contingent upon consistent upkeep, technical knowledge, and resource availability. Radiation and environmental hazards, while mitigated by armor shielding and filtration, remain potential dangers, particularly if protective systems are damaged, improperly sealed, or exhausted, as breaches in plating, filtration failure, or exposure beyond rated limits can result in radiation sickness, chemical contamination, or acute injury. And these vulnerabilities highlight the interdependence of structural integrity, environmental protection systems, and user awareness, reinforcing the notion that power armor enhances survivability but does not render the wearer invulnerable. Fusion core dependence also introduces logistical vulnerabilities, as operational duration, mission planning, and combat endurance are intrinsically tied to the availability of functioning cores, creating strategic constraints for long-duration patrols, exploration missions, or engagements in remote areas, and necessitating careful monitoring of energy reserves, prioritization of subsystem usage, and contingency planning to ensure operational continuity, with failure resulting in immobilization, loss of protective capabilities, and potential fatality, reflecting the critical nature of energy management in power armor operation. Armor-induced fatigue, though mitigated by hydraulic and servo-mechanical assistance, is another consideration. Even as prolonged operation under heavy load, repetitive combat maneuvers, or extended environmental exposure can still impose cumulative physical and cognitive stress on the wearer, potentially affecting reaction times, decision-making, and operational efficiency, highlighting the importance of tactical pacing, rotation of operators, and situational awareness in mitigating human limitations even within mechanically augmented suits. Vulnerabilities to concentrated fire, explosives, or specialized weaponry remain relevant, as armor is not uniformly impervious, with gaps, weak points, or worn sections susceptible to penetration by high-caliber rounds, energy weapons, or armor-piercing munitions, and tactical scenarios involving ambushes, heavy artillery, or coordinated assaults exploit these limitations, demonstrating that power armor provides substantial but not absolute protection and emphasizing the continued relevance of strategic thinking, environmental assessment, and unit coordination when deploying armored personnel in hostile conditions. Electronic and sensor system failures constitute additional operational risks, as HUD malfunctions, targeting array degradation, or communications breakdowns can compromise situational awareness, command coordination, and battlefield effectiveness, and such failures are particularly dangerous in complex combat scenarios, hazardous zones, or during urban fight engagements where timely information processing and environmental monitoring are critical, illustrating the interplay between mechanical, electronic, and human factors in determining overall armor effectiveness. Weight and size also introduce tactical constraints, affecting stealth, maneuverability, and accessibility, as heavily armored units are more easily detected, slower to navigate constricted spaces, and more susceptible to terrain-induced vulnerabilities, creating opportunities for ambush, evasion, or targeted attacks, and requiring careful planning, route selection, and coordination with unarmored or lightly armored support units to maintain operational flexibility. Post-war scavengers and factions must contend with the compounded dangers of partial knowledge, improvised repairs, and hybridized suits, as inaccurate maintenance, incompatible component integration, or incomplete understanding of pre-war systems can introduce malfunctions, catastrophic energy discharge, or mechanical failure, reinforcing the notion that power armor's effectiveness is contingent upon technical skill, knowledge retention, and resource availability, and that mismanagement can transform the suit from a protective asset into a significant liability. Fusion core instability, particularly in damaged or modified suits, introduces the risk of radiation release, explosion, or thermal runaway, requiring operators to follow strict handling protocols, monitor energy output, and implement emergency procedures to mitigate danger, with failures in these areas potentially resulting in lethal injury to the wearer and nearby allies, emphasizing that operational risk is inseparable from the very technology that provides tactical advantage. Psychological factors also play a role, as the perceived invincibility of armored users can lead to overconfidence, risk-taking, and tactical errors, which may result in exposure to environmental hazards, ambushes, or equipment failure, highlighting the interplay between human decision-making and mechanical augmentation, and the necessity of discipline, training, and awareness in maximizing survivability and combat effectiveness. Cumulative wear and material fatigue constitute further limitations, as repeated stress on plating, servos, and structural components gradually degrades performance, reduces shock absorption, and increases susceptibility to penetration or mechanical failure, requiring diligent inspection, preventive maintenance, and judicious operational use to preserve functional longevity, particularly in the post-war context, where replacement parts are scarce and environmental hazards accelerate material deterioration. Finally, the combination of complexity, dependency on limited resources, environmental vulnerability, and human factors ensures that power armor, while transformative, remains a system of calculated risk where operational success depends not only on the mechanical capabilities of the suit, but also on user proficiency, maintenance rigor, strategic planning, and environmental awareness, creating a dynamic equilibrium in which power armor amplifies human potential while imposing strict operational, logistical, and cognitive constraints, and highlighting that the greatest dangers associated with these suits arise not solely from external threats, but from the interplay between technological dependence, environmental hazards, and human limitations, ensuring that operators, factions, and scavengers must respect both the power and the peril inherent in wielding these iconic exoskeletal systems in the wasteland. Ultimately, the dangers and limitations of power armor reinforce the principle that no suit, regardless of model or rarity, provides absolute protection, and that survival, tactical advantage, and operational continuity rely upon a delicate balance between technological mastery, human skill, and environmental management, ensuring that power armor remains simultaneously a formidable asset and a system demanding vigilance, expertise, and respect in the Fallout universe. The legacy and influence of power armor on post-apocalyptic civilization in the Fallout universe extend far beyond its immediate tactical applications, embedding themselves deeply into the political, social, technological, and cultural frameworks of the wasteland, and shaping human behavior, factional development, and the mythos of survival, as the presence of advanced exoskeletal systems fundamentally alters the balance of power, the distribution of resources, and the narratives of identity, heroism, and authority that define communities and organizations across the irradiated landscape. The technological mastery inherent in power armor, inherited from pre-war engineering, represents both a tangible link to lost civilization and a benchmark for what is achievable when human ingenuity is combined with industrial capacity. With the complex integration of servomechanics, hydraulics, environmental systems, and energy sources, inspiring factions and individuals to emulate, preserve, or adapt these systems, thereby creating a persistent culture of innovation and technological reverence that informs post-war research, scavenging, and adaptation, and fosters an enduring respect for knowledge, craftsmanship, and pre-war achievement. Politically, power armor has been a decisive instrument of influence, allowing factions such as the Brotherhood of Steel, the Enclave, and the NCR to project authority, enforce territorial control, and consolidate power in a world where scarcity, danger, and uncertainty define social hierarchies, with armored units serving not only as military assets, but also as symbols of legitimacy, technological superiority, and ideological dominance, shaping negotiations, alliances, and conflicts across the wasteland, and establishing the correlation between access to advanced technology and political leverage, a dynamic that persists in both urbanized ruins and remote settlements. Culturally, power armor functions as a symbol of identity, fear, and aspiration. With its imposing silhouette, historical associations, and legendary narratives inspiring stories, songs, and oral histories among wasteland communities, creating shared mythologies that influence behavior, social cohesion, and moral frameworks, while also instilling awe, respect, or trepidation. As individuals encounter figures wearing these suits, and communities integrate the imagery of armored warriors into art, ritual, and commemorative practices, reinforcing the cultural significance of power armor beyond practical application, and establishing it as a focal point for social memory and identity. The Brotherhood of Steel's custodianship of power armor reinforces the link between technology and societal organization, as the strict preservation, enhancement, and controlled distribution of suits create hierarchical structures, rituals, and moral codes that prioritize knowledge retention, technical skill, and disciplined stewardship, embedding technological authority within social and cultural norms, and ensuring that the very presence of functional power armor dictates the structure, behavior, and legitimacy of institutions in the wasteland, demonstrating how technology can shape social order and influence intergroup dynamics. Faction-specific adaptations of power armor further illustrate the influence on civilization, as each group modifies suits to reflect environmental conditions, strategic priorities, and ideological principles, with the NCR emphasizing standardized and deployable models to support governance and military operations, the Enclave integrating experimental designs to assert dominance and continuity with pre-war authority, and raider groups creating hybridized or improvised suits to establish localized power, intimidation, and identity, collectively demonstrating how the armor functions as both a technological asset and a societal symbol, shaping factional identity, territorial control, and operational doctrine while inspiring innovation, competition, and emulation among rival groups. The existence of legendary and iconic suits contributes to a living historical consciousness, as specific armor units and their wearers become the subjects of storytelling, legend, and communal memory, providing moral exemplars, cautionary tales, and aspirational figures whose deeds and resilience are recounted across settlements, military training, and scavenger narratives, thereby ensuring that power armor informs not only practical survival strategies, but also the moral and cultural imagination of post-apocalyptic society, reinforcing values of courage, skill, and technological mastery. Technological influence extends to scavenger and settler communities, as recovered or partially functional suits provide both tangible benefits and aspirational models for innovation, modification, and engineering, motivating individuals to experiment with mechanics, hydraulics, and energy systems, while also cultivating an understanding of pre-war industrial processes, material science, and operational protocol, which in turn contributes to the incremental recovery of knowledge and the rebuilding of technical capability, demonstrating that power armor's legacy includes the preservation and dissemination of pre-war scientific expertise, even amid societal collapse. The psychological and social impact of power armor on civilization is further reflected in how it structures relationships between factions, communities, and individuals, as the possession, display, or operational use of armored units conveys authority, expertise, and survival capability, influencing social hierarchies, negotiation dynamics, and conflict resolution, while also creating aspirational benchmarks for personal and communal achievement, effectively embedding technological mastery into the moral, cultural, and political fabric of post-war society, and shaping expectations, norms, and behaviors at multiple scales of social organization. Environmental and tactical influence is also evident, as the enhanced survivability, mobility, and combat capability of armored units reshape approaches to exploration, settlement expansion, and territorial defense, enabling groups to access irradiated zones, fortified ruins, and contested regions that would otherwise be untenable, thereby extending the geographical reach of civilization, facilitating resource acquisition, and redefining concepts of security, resilience, and strategic control. with power armor functioning as both an enabler of expansion and a determinant of tactical and territorial opportunity. The legacy of power armor is also manifested in education, training, and cultural transmission, as factions such as the Brotherhood of Steel institutionalize knowledge of armor operation, maintenance, and tactical employment, while legendary suits and their historical narratives are incorporated into recruitment, moral instruction, and ceremonial observances, thereby ensuring that each generation inherits not only the technical capability, but also the cultural significance, operational doctrine, and ethical framework associated with these iconic systems, perpetuating a cycle in which technological mastery and cultural continuity reinforce one another. In the realm of conflict and diplomacy, power armor shapes the strategic calculus of factions and settlements, as its deployment influences perceptions of strength, deterrence, and operational capability, while the threat or presence of armored units affects negotiation, alliance formation, and risk assessment, embedding the technology into the political and social mechanisms that govern wasteland interactions, and reinforcing the principle that technological superiority is inseparable from societal influence in a resource-scarce, high-risk environment. Power armor's influence also extends to myth-making, propaganda, and storytelling, as suits and their wearers become symbols of heroism, fear, resilience, or authority, inspiring legends that shape communal behavior, moral reasoning, and aspirational goals, while simultaneously preserving historical memory and reinforcing factional narratives, ensuring that technology continues to play a formative role in shaping social norms, values, and collective imagination long after its initial deployment. The operational and symbolic prominence of power armor reinforces technological stratification, as access, proficiency, and maintenance expertise create social and organizational hierarchies, with those capable of operating or preserving armor attaining authority, prestige, and influence, demonstrating that the legacy of power armor encompasses not only mechanical and tactical dimensions, but also the structuring of social order, leadership legitimacy, and cultural identity in post-apocalyptic civilization. The continued relevance of power armor in exploration, combat, and factional politics ensures that its influence permeates multiple aspects of wasteland life, from small settlements defending against raiders or irradiated creatures, to major factions conducting military operations, territorial consolidation, and knowledge preservation, illustrating the interdependence of technology, societal development, and cultural continuity in shaping the post-war human landscape. Ultimately, the legacy and influence of power armor on civilization are profound and multifaceted, encompassing technological preservation, operational mastery, cultural symbolism, factional identity, social hierarchy, psychological impact, and myth-making, ensuring that these advanced exoskeletal systems remain central to the organization, perception, and evolution of human society in the Fallout universe, and that their presence continues to define the possibilities, limitations, and aspirations of civilization in a world reshaped by nuclear devastation, scarcity, and the enduring human drive to survive, innovate, and assert mastery over technology and environment across generations.